Hello everybody and welcome to Brain Linker. In the previous video of collection series, we had discussed array list. In this video particularly, we are going to discuss the linked list. I think it's a good idea to start with a roadmap. In order to understand linked list class, we must have to know some basic terminologies so that you will not find some strange words in the upcoming videos. Let's see what they are. First is data structures. In order to understand linked list class, we must have to take a brief look at data structure because linked list class is actually an implementation of linked list data structure. Hence, we will first understand the data structure as a basic terminology. Then we will understand linked list as data structure, what linked list provides to the data structure. And the third one is linked list types. There are a number of types of linked lists such as singular linked list, doubly linked list, circular linked list. We will see each one in this video. And the fourth is linked list class hierarchy. First of all, we will start with data structure. A data structure in a simple term is a way of organizing data. There are a number of ways in which you can store your data. For example, if you want to store 1, 2, 3, then there are multiple ways in which you can do it. One of them is contiguous manner. As you can see in the memory, each element will be stored at contiguous location. Second one of them is non-contiguous manner. Conclusively, there are multiple ways in which you can store your data, and each one has its own advantages and disadvantages. The study of all these can be tagged as data structure. Now we have a basic idea of what data structure is. So we are good to go to the linked list as data structure. We will understand it by comparing with array list, or more specifically I can say array. So the first question should be in your mind is how array stores its elements. One straightforward answer is in a contiguous manner. For example, if you want to store an integer array that has 2 elements, in Java, as we all know, one single integer element acquires 4 bytes. Suppose we assume that each given memory location is of 1 byte, so collectively 4 memory locations acquire 4 bytes, which we actually call node. In our example, that can represent an integer. As I said, the elements are stored in a contiguous manner. Suppose first element requires 4 bytes, then the next element will be at the next contiguous location after the 4 bytes. Hence, in order to access successive elements, runtime knows that at successive addresses, it can find it. But disadvantage of this kind of data structure is that we need to have contiguous memory locations. Otherwise, it will not accommodate more elements even if we have enough scattered space. For example, if we want to store another integer array that has 2 elements, we need 8 bytes of memory available. Current scenario is depicted in the slide. We have 4 bytes available at 1005 to 1008. And we have another 4 bytes available at 1013 to 1016. So all in all we have 8 bytes available, but the problem is it's not contiguous. That's why even if we have enough space, we cannot accommodate 3 and 4. That's where the linked list comes into the picture. Let's see how the linked list organizes its data to solve the problem. Let's take an example. Linked list has nodes to represent data as similar to array, but here each node has 2 parts. First is data part and the second one is address part. Data part stores the actual element and the address part stores the address of the next element. So each node has address of the next element. Last element's address will be null. And then there is a head pointer which points to the first element of the linked list. You might think, what is the advantage of having both data and address in a single node? The purpose of having address part is to eliminate a need of contiguous memory. Because each node has address of the next element, we can store each element anywhere in the memory. In order to access successive elements, runtime knows that each node has address of the next element. It can use it to find or access successive elements. But as you all know, there is no one perfect in this world, so there is another side of the coin too. There are disadvantages too. One can be seen is a need of memory to store these addresses. Now we are good to go to the linked list types. First is singly linked list. Second one is doubly linked list. And the third one is circular linked list. The linked list that we have seen so far is singly linked list. Hence, let's understand doubly linked list in brief. Doubly linked list is same as singly linked list except one change. In addition to data and address of the next node, it also has address of the previous node. All in all, a single node has three parts. First is address of the previous node, then data part, and at last address of the next node. One thing to note here is first element's previous address and last element's next address will be null. Third type of linked list is circular linked list. Actually, circular linked list has two variants in combination with singly linked list and doubly linked list. One of them is singly circular linked list. It is a combination of singly linked list and circular linked list. Let's take an example and understand what it says. Singly circular linked list is same as singly linked list except one difference. Last element's next address will not be null. Rather, it points to the first element of the linked list. Then the second variant, doubly circular linked list. It is a combination of doubly linked list and circular linked list. Doubly circular linked list is same as doubly linked list except two difference. First element's previous address and last element's next address will not be null. Instead, last element's next address will point to the first element of the linked list. And the first element's previous address will point to the last element of the linked list. Then, last topic of the video, LinkedList Class Hierarchy. LinkedList class extends and implements several classes and interfaces. Let's see each one. First is Deque. LinkedList implements Deque interface. Then it implements list. Then it implements clonable. Then it implements serializable. And at last it extends AbstractSequentialList. These all provide different behaviors to the linked list. I will explain only the newer things. Serializable, clonable, and list are implemented by more than one collection. Hence, I will not explain that in each and every collection video, because that would make every collection video unnecessarily long, and explaining same concepts makes the task boring for me too. Rather, I have explained those three in the second video of the collection. I have given a link in the description, or you can find it out in the eye icon at the top right corner. So currently we are starting with AbstractSequentialList. This class provides sequential access behavior to the linked list, as opposed to abstract list of array list where random access behavior is provided. For example, if we want to find or access particular element in the given linked list, we need to traverse through all the elements from the head node to the specified node. So that behavior is provided by AbstractSequentialList. Second one, Deque. Deque is short of the double-ended queue. In Deque, insertion can be made at both top and bottom ends. At this moment, that's all you need to know. We will discuss Deque in more detail in a separate video. That's it for today's video. If you like this video, then please press the like button. If you haven't subscribed, then please press the subscribe button. You can give your feedback or doubt in the comment section. Goodbye.